Hey everyone, I wanted to take a moment this morning to show you a little demo I put together using Docker Compose and Docker Model Runner. So I've uploaded this code to my GitHub repo, and you'll see there's a pretty small repo here, just some apps. There's two little apps and a bin directory where I keep my Docker Compose file. To get started, typical process I use is a .env file, so just make a copy of this, save it as .env, and run your Docker Compose. Let me jump over to the code and I can show you what this does. So for this, here's my Docker Compose file. It's here in the bin/local directory. My typical process is bin/local for local development, then there would be other directories in there for different environments. Here, I'm just giving the Compose project a name, and then for the services, there's an example of a very basic, just pulling a Redis image, grabbing the latest. Second example here, we're going to spin up a database. It's going to be Postgres. I'm pointing to a custom Docker file here in the apps/db directory, which is up here. We're going to expose a port, include my environment file, and tell it where to put the data, and an initialization script to create my tables. This will only run on the first startup of this image. So here's that Docker file for this database. Just using the 17.5 Postgres, and going to install pgvector. And I'll show you why in just a moment. In the initialization script, we're going to create just a couple of tables here. One for documents, and we're going to use that vector data type. We're actually also enabling the extension up here, and then using that vector data type, and then a conversation. So what we're going to do is create a very, very basic RAG, not something production worthy, but just something to demonstrate how you can use a few different components together in a Compose file. Back to the YAML, we've got another service here, which is Docker Model Runner. So we're telling it it's going to be type model and specifying my model here. I've played with a few different ones, and we'll just go with this one for now. And finally, we've got an API. This uses fast API with Python, a very small application. Going to point to our custom Docker file, expose the port 9494 out. We're going to watch the requirements.txt and rebuild if it changes, and if we see any code changes, we're going to sync that into the image. We're going to include our environments file. We'll need that. And then finally, we're going to depend on these other three services. So this one won't be ready until these are ready. So let's take a quick look at how this looks running. So I'll stop the container. I had it running. So we're going to Docker Compose up, and we see everything has started up. It'll take just a moment here. Okay, we are ready on port 9494. So if I go to my web browser, let's go back. So here's our web app. I've got some documents and a couple endpoints for conversations. So how this works is you can upload documents using this post, and I've already uploaded one, so I can use this documents endpoint, and we can see that I've uploaded one document, and this document is some basic rules to style a web page. So we're specifying the font, telling it I want it to be a bold font for the headings, 0000, which is black for the color, size, border, and paragraph styles. So hopefully what we're going to do is ask this LLM through the API to provide me some CSS I can use in my web page. So here's going to be my prompt. I'll come back over here, and we'll do a post to the conversations and put my message here and run. This might take a moment. Admittedly, it's not quite as quick quick as, say, a cloud hosted LLM, but it works just fine for testing and small demos. Here we go, we have a response. It didn't take too long. Brief explanation, and we do have some CSS here, and that does look like the requested body and the color of the heading and a border on the bottom. I remember that's the settings I'd requested. So that's a quick overview of the API. Now I'll show you kind of how that works. So if I come back over here in the API, here's our simple Docker file. I don't think I showed this previously, but we've got a requirements.txt. We're going to bring that into the image. We're going to run pip install to install those requirements and copy in my app code, which is this directory here, and expose the port and tell it how to run it. So in the application, we've got models, routers, and some utilities. The routers are what we saw in the web page, conversations and documents. If you recall over here, you'll see that those are the two sections I have, documents and conversations. And the documents is just the basic CRUD utility to upload documents. I won't go into that, those basic stuff. In the conversations, however, you'll recall we are calling an LLM model. So to get that, Docker model runner is going to set these environment variables for us. That gives us a URL and the model name. So we'll use that further down to call the API. So this function takes the user message. It creates a request that goes to that URL, and we create a post request to it. The response we get back, we're going to parse that out and find the response and throw an exception if it doesn't find it. You also recall we created a documents table using the vector extension in Postgres. So how that's going to work is this is our endpoint to create a post request to the conversation. So we'll first create an embedding of the user message that was sent, but then we're going to query the database and find the 5 closest documents. I've only uploaded one document, but the same logic applies. So this function is further up here. You can see we're just doing a select from the document, just using SQL Alchemy. I'm going to order it by the L2 distance, which is provided by the vector extension for SQL Alchemy. You can see up here the models. If I open up document, I'm including this pgvector.sqlalchemy extension. This is something I did have to add to my requirements file as it's a separate package. And then I specified the data type. So back to here, request the limited list of documents, and then back down in my endpoint code, after I retrieve the documents, I'm going to create the context string. So I'm going to append all those together, and here's my actual prompt. So I'm going to tell it it's a coding assistant and use the documents as context and answer my question. And that's how we get the response back. So that's all there is to putting together a simple Docker Compose project. You can create a very basic RAG with very limited code. You can call an LLM locally and get a response back. And hopefully you can do a little development and save a little cost running things in Azure. So appreciate you joining me. Check you out next time. Thanks.